To this point, we've learned to graph quadratics by finding the vertex using the negative b over 2a concept and then plugging that back in to find the y-coordinate of the vertex. But what we're going to do today is we're going to look at how to graph quadratics that are in a what we call a vertex form, or y equals a multiplied by the quantity of x minus h squared plus k. Now you'll notice that this equation looks a lot like our square root equation that we talked about 3 weeks ago. And it turns out that a, h, and k have very much the same effect on quadratics as they did on the square roots. In fact, h translates the origin, or your vertex in this case, left and right. K translates the origin up and down. A is still a y multiplier. And when the absolute value of A is greater than 0, we get a narrowing parabola, or what we call a vertical stretch. When the absolute value of A is less than 0, we get a parabola that's a little bit wider than what we would normally see, and it's called a vertical compression. And finally, when A is positive, the parabola is going to open up. When A is negative, the parabola opens down. We also say that reflects over the x-axis. And our parent function, once again, is y equals x squared, 0, 0, 1, 1, 2, 4, and 3, 9 as our general pattern for that. So let's go ahead and graph some of these functions using the idea of these transformations. And we'll identify things as we go along. So we see, in this case, there's nothing inside a set of parentheses squared, so we know that h is equal to 0. There's nothing in front of the x squared term, so that means a is equal to 1. And then outside of the squared term, we have a minus 3, so k equals negative 3. So what that tells us is it tells us our hk, or our origin, is now at 0 and negative 3. So I'm going to go to 0 and negative 3 and put a little new axis down there. And from that, I'm going to look at y equals ax squared, and in this case that's just 1x squared, and graph the parent function from that new origin point. So from this point, I'm going to move over 1 and up 1. And I'm going to do that on both sides since I know there's a line of symmetry going down that. I'm going to move over 2 and up 4. And then go over 3 and up 9. And then, as always, it's a great idea to take and check what you've done. So here's my parabola. And I have this point of 2, 1. And I'm going to see if that fits. If I plug a 2 into x, I get 2 squared minus 3, which is equal to 1. So the point 2, 1 actually exists on the graph. Now, not only does this ask me to graph this equation, but it asks me to describe the relationship to the parent function. Well, my relationship would be translates 3 down and same shape as y equals x squared. Let's move to our next problem. You'll notice in this case we have this number out in front, which is our a value. So a is equal to 2, and that's our y multiplier. And then we have a number inside. So any number that comes after a subtraction is the actual h value. So h equals 4. There's nothing on the outside, so k is equal to 0. So we know now we have a origin of 4, 0. So I'll go over to 4, 0. put this here. I know a is equal to 2, so I'm going to look at y equals 2x squared. Well, y equals x squared is 0, 0, 1, 1, 2, 4, 3, 9. But I have this y multiplier of 2, so I'm going to multiply all those values by 2 and get a 0, a 2, an 8, and an 18. 18 is going to be a little bit big, but we'll do the other one. So here's 0, 0 over 1 up 2, and I do that on both sides since I have a line of symmetry. And then over 2 and up 8 from there puts me here. So you'll see that this parabola is much narrower than our previous parabola because of this y multiplier of 2. So we say we have translation 4 to the right and vertical stretch of factor 2. And that's how that compares to the original graph of y equals x squared. So here's a similar problem. In this case, we have an a value of a half. And remember, we want this to be in x minus form, so this is a half of x minus a negative 1 squared. So we have an h value equaling negative 1 and a k value, again, of 0. I'll move over to negative 1, 0, put my little new origin down here. I'm going to now look at y equals x squared once again. So here's x and y, but this time I'll take and multiply my y values by a half. So I have 0, 0, 1, 1, 2, 4, 3, and 9. Multiply all those by a half. 0, a half, 2, and 4.5. So here's my 0, 0. I move over 1 and up a half on both sides, over 2 and up 2 in this case, and I'm going to probably want to check that. I know I forgot to do it in the last problem, but this graph appears to be wider than our previous graphs. So I'm going to check a point of 1 and 2. Let's pop that in here. I have a half times 1 plus 1 squared. That's going to be a half times 2 squared, which is a half times 4, which is 2. So the point 1, 2 actually checks. How does this compare to the parent function? It translates 1 left and vertical compression factor 1/2. In this next example, you'll see now that we have two numbers involved in our translation, we have both an h and a k. A is equal to 1 because there's an invisible 1 out front. H is equal to 2 because it follows the subtraction sign. And k is equal to a positive 1 because it follows an addition sign. So now we have our origin at 2, 1. I'm going to move over 2 and up 1. Put my little cross section there. Graph my parent function from that. 0, 0, 1, 1, 2, 4, 3, 9. There's 0, 0, 1, 1, 2, 4. And this is the exact same shape as my parent function y equals x squared because there's no y multiplier. So really all that's happened here is I have translation translates 2 right, 1 up. And let's just check a point for kicks. We've got 3 and 2. I'm going to plug that in. I'll take 3 minus 2, square it, and add 1 to it. That gives me a 1 squared plus 1, which is 2. So it checks. So once again, you'll notice we have an h and a k, and there's actually a -1 out front. So our a value is -1. Our h value, we have to rewrite this. So this goes to -1 x minus a -4 squared plus 2. So h in this case is -4 and k in this case is 2, which means our origin is at -4 and 2. So I go to -4 and up 2, do that little crosshair. It's my new origin. I look at y equals x squared. So here's x and y, 0, 0, 1, 1, 2, 4. And I'm also going to multiply my y values by a -1. So when I do that, I get 0, -1, -4. So I start at 0, 0, move over 1 and down 1, over 2 and down 4. Puts me here. So how has this changed? Well, it appears we have a vertical reflection. But it's still in the same shape as y equals x squared because I have a 1 here. The negative reflects it though. And then I have a translation for left to up. And if we want to check a point, I can check -3 and 1. Let's just plug that in. So I have the opposite of -3 plus 4 squared plus 2. That's -1 squared plus 2 gives me, what's that give me? It gives me a -1 plus 2 is 1. And I was trying to get -3 and 1, and that's what I got. Let's move to our next example. So now we're going to take and look at this problem. We have an a value of -3. We have h value equal to 0 because there's nothing in the parentheses, and a k value of 8. So that means my origin is at 0, 8, and I'm going to graph y equals x squared of 0, 0, 1, 1, 2, 4. And I'm going to take and multiply those values by a -3 for my y, so that's 0, -3, and -12. So if I look at 0, 8, puts me roughly here. There's that origin, 0, 0, 1 and down 3 from that point, and over 2 and down 12 puts me here. Clearly this is a much narrower graph. Whoops. And how is that compared to the original? Well, we have a reflection. We have a vertical stretch. Factor 3. And we have a translation. It's 8 up. Got one more. We'll combine everything together now. We have an a value, 2, h value, 5, k value, -9. So this means our origin is at 5 and -9. We're looking at our parent function 0, 0, 1, 1, 2, 4. Going to multiply those y values by a factor of 2, 0, 2, and 8. So I'm going to move over 5, 1, 2, 3, 4, 5, down 9. Put my little new origin marker here. Here's 0, 0, over 1, up 2, over 2, up 8. Whoops. Go ahead and graph that. Check those points. Let's go ahead and use 4 and -7 as a point to check. That's this guy right here. I plug a 4 in, I get 2 times 4 minus 5 squared minus 9. This is 2 times -1 squared minus 9, which is 2 minus 9 or -7. So that checked out. So how's this compare to the original? Translate. We went 5 right, 9 down, vertical stretch, factor 2. Again, this is a lot like our square root lesson. We're not plugging in straight points anymore. We're using the concept of translations to do our graphs. Write your lesson summary, answer these questions, and we'll discuss this more tomorrow.